Hi everybody, my name is Brian Terrell. In my past life, I was a professional refrigeration and commercial air conditioning service technician. Now I am a teacher. I teach air conditioning refrigeration to students at our local career tech. Okay? So I don't think that there is anybody that is more qualified to do a review on a icebox than me. There are some people out there, but I'm probably about as good as you're going to get. So today we are going to be performing a review on this Iceco portable refrigerator. Okay. So the first thing we're going to notice is well, this thing is white. It's very white. That's okay though. One thing I do like is it's got these nifty little handles on the back end, so that you can. They're kind of hard to get a hold of, but you can't complain too much. As you can see, it's got some vents in here. This bad boy comes with a Danfoss compressor, which in our industry, you know, the refrigeration industry, that's a pretty well-known name. They have really good quality. You can see that there are, you know, buttons on here. We got on, off. We've got a lock button. You can adjust it up and down. It's supposedly reading, with accuracy. We will test that. The temperature that is inside the box, or perhaps that's the set point. I don't know. We'll discuss the difference between that. It's got a lock on the lid. You have to unlock it, lift it up. Look at that. Is that high performance or what? Yeah, there's a light in there. Here's a good look at the data plate. This is the Model G012 Whiskey Sierra Sierra refrigerator. This is not the bigger model that has the divider, okay? And has a freezing capability, although this one supposedly can go down to, what was it? I think the lowest set point is 0. I'm going to make sure. We've got this little bit of product in here, but I can feel it is definitely cooling. As you can see, it closes slowly on its own. Oh, there we go. Well, there it goes. It also comes with the original one comes with a 12-volt plug on the end of it. And of course it has an adapter, 115 volts, which I've got plugged in over here on the wall in my office. Yeah, this is not a field one. This is actually in my office. You can kind of see. Yes, I'm a teacher, so I have an office. But we're going to conduct some experiments, and we're going to let you know exactly what this thing will do. Okay, we'll get back with you. The first experiment that we are going to do on this Iceco refrigerator is we are going to test to see how accurate the actual temperature control on this bad boy really is. Now, first thing I want to say is being a professional in the refrigeration industry for many years, more years than I want to admit, a good quality precision thermometer is something that's kind of hard to come by. So the first thing we got to do is we got to test the thermometers that we are conducting this experiment with. Okay, so first thing we need is a constant. And what is a constant temperature that we know 100% is accurate? Well, I mean, I could say it's 72 degrees in here, but you probably wouldn't believe me. So what we're going to do is we're going to get something that everybody knows. Right there. See that? It's ice water. Okay? Everybody knows that a mixture of water and ice is what? 32 degrees. And we are close enough. We're close enough to sea level here in Oklahoma that it should afford us a certain amount of accuracy. So we've got 3 thermometers that we'll be conducting this experiment with. Number 1, we have the Cooper. Okay? Cooper, it is showing that deal of ice, water, is 32.2 degrees. I would say that's probably in the ballpark, wouldn't you? Now here we have a lesser degree thermometer, okay? And as you can see, it is showing 32.7, 32.5 degrees Fahrenheit. I would say it's definitely in the ballpark too. And like I told you, not all thermometers are 100% accurate, but this one is pretty close. It's showing 35 degrees Fahrenheit. So I would say it's safe to say that this one is 3 degrees high. So we're going to make a mental note of that, and we're going to put them to use. Okay, sadly, we were not able to use the good Cooper thermometer because apparently the probe thickness on this bad boy, you can tell it's a brand new probe, is a little bit too thick in order for it to go through the seal and still close and lock the door. These other two thermometers, their probes are very, very thin, so I was able to get them in there and shut the door so that we can have a good seal. I don't know about you, but my thoughts on that are, that's good. That's actually good that the thicker probe would not fit in there. That just means it's got a better seal in my opinion. We'll see. All right, it's been about 30 minutes and we're gonna check and see. This bad boy says it is 29. This one says it is 24. This one says it is 29. Well, now I just switched to 27, so apparently it's, and it is, I can hear it running. So, split the middle, I would say it's definitely in the ballpark. It's not that far off. So it's a pass for that test. Now for our next experiment, we are going to actually put some product in here. This is 1 gallon of water. It is already pre-refrigerated. And what I've done is I've taken these sensors and I have tied these sensors off to the handle, okay? I've positioned both of these probes to where they are sensing the temperature of the air. They will not be up against the side or something like that. They could give it a tainted or a false reading, okay? And what we're gonna do is we're gonna shut this bad boy down and we are gonna let it refrigerate for 30 minutes and then we're gonna unplug it. After we unplug it, we are going to let it sit as if, say, you were out on a camping trip and you just shut your car off, okay? My question is how long will it take before that ice box begins to warm up? Okay, so is it going to be, is your food, the product, is that going to be hot in an hour? Is it going to be hot in 4 hours? Is it going to be hot in 10 hours? We're going to find out right here. Okay, we may not be out in the field, but we do have a controlled environment here. And of course, it'll probably depend on what your outdoor ambient temperature is. How hot is it outside? This office is like 70 degrees. So we're going to conduct this experiment and we're going to see just how long it will keep powered down. All right, we've been sitting for a little while. We got 35 degrees and 37 degrees, normal refrigerator type temperatures. So we're going to go ahead and we're going to unplug it. As you can see, we just powered down. Here, I'll show you on my desktop computer. It is now 11:35 a.m. Here we come back. It is 1:24 p.m. Not quite 2 hours. And what do we got here? We've got 46 degrees, 48 degrees. She's definitely going up. But this still, 46 and 48 degrees is still really good temperatures for keeping food. You're not going to have any spoiled, any spoiled food or anything.
2 hours later.
And we are sitting at 50 degrees and 53 degrees. Well, we started at what, 7:30? that's doable. I think the reason for the refrigeration difference is, or the temperature reading difference is, I'm pretty sure, keep in mind this thing is loaded and yeah, the water's cold. I think the sensor is somewhere over here and I'm taking temperature readings from over here. So 7:30 to 8:51, that's a couple of hours, but you're actually pulling down a loaded box. That's interesting. The walls are nice and cold. Yeah, you can definitely tell it's refrigerating. Probably would have pulled down a lot faster if it wasn't loaded with a gallon of water that needed to be refrigerated. Anyway. See how I just unlocked it? Now for our next experiment. Can it freeze the water jug? That's going to be pretty tough. And the reason why I say that is a gallon of water. That's a pretty hefty duty load for such a little bit of refrigerator. Well, hot doggity, we're starting to get frost. So apparently, this thing has the ability to freeze. Wow. I'll be dogged. I'm actually really impressed. Well, let's see what it says. 20. There's a big difference there. Holy crap. Guys, there's a little liquid left in there. Holy crap, that thing's pretty much frozen solid. Like 98%. Oh, look, there's even frost right here. There's frost on the inside. This is a little, wow, this is cool. Well, I'm impressed. Now it's time to put it in the Subaru and put it to work. To wrap this up, I found the Iceco box to be well made. A much better box than most other competitors. I recommend this.